So today we'll be going over server-side diff. You may have heard of it from a little bit from the last talk, but we'll be doing a deep dive into it today. So quick introduction, my name's Peter. I'm a software engineer at Intuit and a new maintainer of the Argo CD open source project.
Hello everyone, my name is Leonardo. I usually go by Leo. You heard my name a lot in the previous talk. So I'm a staff software developer at Intuit and an Argo maintainer. So starting off with a quick agenda for our talk today. So I'm going to go quickly providing an intro on what we're talking about. Want to provide some of the problems that we faced with client-side diff. Explain a bit on how server-side diff works behind the scenes. Then I'll pass over back to Peter, who's going to be talking about some advantages of server-side diff, some drawbacks, and lessons learned. Cool? All right. First thing first, we both work at Intuit, and the company provides us a lot of incentive to open source in general. So you may not know Argo CD and Argo rollouts. They both were created inside Intuit, and later on they were donated to CNCF. And we have a new kid on the block, the Numa Proj, the icon that you see right next to Argo. If you want to know more about the project, please consider joining us in the Intuit booth. Some numbers from the company. We operate on 300 plus Kubernetes clusters. We have more than 3,000 production services, over 50K namespaces. Why I'm saying all that? Basically, to show you the size that we operate in the company and how whenever we enable new features in Argo CD, this is the type of platform that we test on top of, right? And server-side diff is no exception to this rule. All right, let's talk about server-side diff and why we're even having two talks about diff in this ArgoCon. Why is that even important, right? So diff in Argo CD is one of the core features, and what I mean by that is it is used to determine the application state. So think about the Argo CD application controller, right? It runs inside Kubernetes. It has this reconciliation loop. But what actually determines if the application is out of sync or not is not the application resource, per se, simplifying things a bit, is the result of the diff operation. We need to compare what you have defined in the desired state with the live state in Kubernetes, see if there is any difference from that whenever that gets applied, and that what drives the application state, right? So it's really, really important. It's one of the core features in Argo CD, what makes it possible. It also allows you to visualize before applying, so it's a very, very, very important feature. So, and it provides control and confidence, right? So you can very safely understand what is about to change in your live environment before syncing. Okay, let's talk about the client-side diff. So if you're not aware of, when Argo CD first shipped, the logic that we had implemented was the client-side diff. So everything happens inside the Argo CD controller. But what are the problems with that? So let me show you this. Let me drive you through this diagram. If you think this is complicated, bear with me. Let me try to drive you through that. So starting from top down, right? So the new config that you see there on the top, that represents the desired state. Whatever you have that living in Git, so you push a new commit, that's the new config that will come in, right? The way the three-way merge diff works, which is what the logic that drives the client-side diff, is by applying this logic here. So it will first compute a diff comparing your new config with the live state, the thing you see on the left side. That generates the live diff. At the same time, parallel to that, it will apply the same logic, but on top of the last applied configuration annotation. So if you don't remember, that's not a problem. Almost every Kubernetes resource, and I'm saying almost because I'm going to get back to this in a second, has this annotation here. And if you notice that in blue, the annotation is actually managed by kubectl. It's a kubectl annotation, right? So kubectl is a tool that will grab the last applied configuration. It will persist that entire resource state inside this annotation. So then we extract the diff based on that, comparing the new config and the last applied configuration. That generates the last applied diff. We merge those two, which generates this merge patch, right? And then we use this merge patch to apply back into the live state. And when you compare the live state with this predicted live state result from this merge, that's the diff you see in Argo CD. So that sounds okay, right? But what are the problems? Why we want to change that, and why we worked so hard to have server-side diff available and now in GA, right? So the first thing is to keep in mind is this annotation has a size limitation. That was the first problem that we faced. So resources that are big, so CRD is the first example. So it has lots and lots of attributes inside. Imagine that you need to get that entire state and put inside an annotation that has size limitation. If our diff logic is relying heavily in this annotation, it kind of breaks our diff, and we're going to be starting presenting diffs that are not expected. So this is the first problem. Second problem is somehow fragile, right? And what I mean by that is, imagine that Argo CD uses kubectl as a library behind the scenes when it applies, so that last apply configuration is updated. But let's say you have access to the production environment or whatever environment, and you have access to your shell. You do through your CLI kubectl apply, and maybe you want to change something that you don't want it to be managed by Argo CD. You want maybe change, add a new label or change an annotation in the resource. The problem is when you do that, it will update the last apply configuration, right? At that point in time, Argo CD thinks that it manages those fields, and you start getting conflicts and you start dealing with those ignored differences. So that's what we mean by fragile. And the next one is server-side apply incompatibility. So it has some level of incompatibility when you sync with server-side apply. And why is that? So again, back to that annotation, server-side apply is something that happens on the server side. So you basically send your desired state to Kube API, and Kube API is the one that is going to calculate the diffs internally and apply or whatever, and it returns back to the client, right? The annotation is not necessarily updated in all the cases, so and that causes a problem, right? Because if client-side diff relies on that annotation, you'll start seeing inconsistencies. And in the client-side diff, there's no notion of schema. I'm not going to go deep dive into this because it is a whole new story. Maybe there's it could be an entire talk just to mention about and explain how about Kubernetes schema works. But think about it, like in the schema you have information, crucial information that is necessary when you're calculating diffs. Things like default values, for example, that are automatically applied in the cluster, even if you don't specify in your desired state. This is a crucial information when we're calculating the diffs, and this is not available in client-side diffs. All right, let's understand about enough of client-side diff. Let's now understand about server-side diff, right, and how that works. Again, another diagram. Hopefully, this is much simpler than the other one. And here, what I'm representing is Argo CD has this boundary, and what I'm trying to represent here is the components that lives inside Argo CD, and now the new config is, in order for us to calculate the predicted live, we invoke a server-side apply in dry run mode. So server-side diff is nothing more than running server-side apply, delegating that logic to kubeAPI, who knows how to calculate the diff properly, in dry run mode. So then we get the predicted live. The thing that was mentioned in the previous talk is the mutation webhook, right? Because now, as we apply, and is Kubernetes who's actually generating this predicted live, we have together returned from kubeAPI changes done by mutation webhooks that runs in the server. And we understood from the maintainers group that not the majority of the users wouldn't want to have mutation webhooks automatically being displayed to them. So the way we understood is, let's remove the mutation webhooks from the predicted live and provide a feature to the community. So if they want to see what are the changes, then they can enable, which is what Gerald presented in the last talk. But by default, we're going to be removing those. And because we're always sending requests to Kubernetes, now we have to have this more aggressive diff cache, and that's what we do at the end. Okay, let me drive you to some characteristics of server-side diff, right? So now, different from client-side diff, server-side diff is 100% based on Kubernetes standards, not kubectl standards, which is the managed fields. Peter is going to go through that in more details in a second. The whole goal, and we want to avoid our users, Argo CD users, having to rely on ignored differences. We understand this feature as a kind of annoying feature, right? So the idea is our goal is to implement the diff logic in Argo CD in a way that it does everything automatically, right? It doesn't require users to go and provide specific configurations on what exactly needs to be ignored or not. And server-side diff is one step in that direction. Now we have admission controllers considered. Think about it. Admission controllers, we have two types, right? Mutation webhooks and validation webhooks. Those two types of admission controllers are now considered during the diff state. So Peter is going to go through that in a second as well. And we have a more aggressive strategy for caching, which is a requirement because now we're sending those requests that goes out of the Argo CD controller to kubeAPI, so we need to have a little bit more aggressive cache. And with that, I pass to Peter, who's going to continue.
Thanks, Leo. So I'll be going over advantages and why you would want to use server-side diff. So the first one is catching issues before you sync. So with server-side diff, we're now validating your manifest against Kubernetes before we sync using the kubectl apply with dry run mode. And this in turn will give you more confidence when you sync to your cluster because we've actually done a dry run against Kubernetes. And I have a diagram here of a flow of how the diffing would work. So let's say we have our Git here, we make a commit, and we would see the changes in Argo CD. And inside the diff, with server-side diff, we would be able to catch any issues. Maybe we made a typo. Now we can go ahead and fix that in Git again, see the new changes reflect, and now we're good, no diff. So we can go ahead and sync, and our application is healthy, and our cluster is nice and synced. So I'll go ahead and show an example. So let's say we make that error when configuring our manifest in Git, and now we see a comparison error because our schema is violated. So looks like in this example, we have an error calculating the server-side diff, and the spec pod template field is not declared in the schema. So yeah, we looked at our manifest, and our resource does not actually have that template field. And now we can go ahead and fix that issue before we sync the change. So why is this good? In the diff stage, since we caught this error, we never synced our change. And if we found this error while we synced, that could potentially leave our cluster in a bad state, as we could have failed to sync halfway and partially applied resources or left some orphaned resources behind. With server-side diff, we would be in a clean state as we never synced. So the next advantage I want to talk about is admission webhooks. Like Leo mentioned, there's two main types, mutation webhooks and validating webhooks. So with client-side diff, we would only see these errors and validation errors and mutations after we sync. And with server-side diff, we would see those errors, and we wouldn't see those mutations by default, but there is that annotation where we can enable it if the user wants. With client-side diff, we get a little bit less accurate preview of our manifest, as we don't have these webhooks participating in the diff. And also there's a app diff command, which we can actually use those validation webhooks to our advantage in our CI/CD pipelines. So now I'll go ahead and show an example of the webhooks. So let's say we have that admission webhooks, which validate our pod replicas must be under 2. Let's say we didn't know about that webhook and we mistakenly increased the replicas to 3. So now our CI/CD pipeline runs and the Argo CD apps sync, and we get an error. So without server-side diff, you can see our sync failed, and we get that validation error saying we exceeded the maximum limit of 2. And server-side diff, we see a similar error, but we get the comparison error with server-side diff. The important thing to note here is the sync phase. Without server-side diff, we can see the sync failed, 1 or more objects failed to apply. And with server-side diff, we get an error. So like I said before, we could end up in a bad state, as in some of our objects could have applied, some of them may not have, and that leaves our cluster in a bad state. Okay, so next advantage I want to talk about is field ownership tracking. So server-side diff now uses this manage fields to track ownership. And you can see in the example I have here, we have 2 managers, Argo CD controller and Kube controller manager. So Kube controller manager manages the replicas field, and Argo CD controller manages the containers field. So with this, we no longer need the last applied configuration. This didn't really have a concept of ownership, as the last manager who applied could actually overwrite fields from a different manager. And with this, we actually preserve the fields from other managers. So let's say our replicas were updated by the Kube controller manager. Argo CD would not be touching that. And what this means for the diff is that we will not show other controllers changes in the diff, and we wouldn't get these out of sync issues. So the next one I want to talk about is CRDs. So we now have better CRD support for server-side diff. And that's because the diff now has the knowledge of the CRD schema, and we get a few advantages with this. So server-side diff will handle default values now, which I'll talk a little bit more about in the next slide. And CRD, we now handle CRD type conversions in the diff. This will allow the diff to handle different versions of your CRD. And in general, the CRD validations will be more reliable in our diff logic. So default values. So I have an example here of our Git state. Let's say we have our CRD here, and the important thing to note in blue is the default values. So we have pod affinity type, which has the default value preferred, and enable PDB, which has default value true. And then in our Git state, we apply our CR, and note that we did not apply any of those default fields. So now let's go ahead and check the live state. So our live state now has those 2 default fields applied, preferred and true. So let's see what happens when we run a diff. So with the Argo CD app diff without server-side diff, we can see out of sync, and we see these two default values here, and that's annoying. We would have to use ignore differences or actually add that in our Git repo. With server-side diff, we see no differences because the diff is already aware of those default fields, and yeah, it just works. No need to add any ignore differences. So the feature is not perfect. I want to go over some drawbacks of server-side diff. The first one here is Argo CD's performance. So with server-side diff, we actually offload that diff computation to Kube API, and that will in turn affect Argo CD's performance. So we ran a benchmark test with the Argo CD app diff CLI command, and you can see here in the graph, there's about a 3-second or 30% increase in seconds with server-side diff. This may not be a huge difference, but you can see with an application with a huge number of resources, that could add up to a lot, as each resource would equal to one server-side apply dry run. So we're aware of the drawback, and we have a few mitigations so users won't quite feel those effects when using Argo CD. So server-side diff will rely more on caching to improve performance. And also server-side diff actually isn't run on resource creation, as we don't really see those benefits there, and a simple client-side diff should be sufficient. Okay, and the next drawback I want to talk about is the complexity of the managed fields. So with managed fields, it can be a little bit tricky to track if you have many different managers managing different fields and trying to track conflicts. So that can be tricky, and one feature we have is actually the client-side apply migration, which allows you to transfer field ownership of managers which you might not be using anymore to Argo CD to manage for you. And that'll keep your managed fields a little bit cleaner. The next drawback is mixing it with server-side diff with client-side apply, as they're using different underlying strategies, and we could see some edge cases where there might be fields out of sync. And I would say the best way is to use a server-side apply with server-side diff so we don't see those issues. And that's just the example of the annotation we would add to our application. You can see I have my manager. You would replace that with the manager which you want to transfer your fields to Argo CD. Okay, so while running the server-side diff at Intuit, we have a few lessons learned. So it's important to validate the performance, to test the performance of server-side diff, making sure it works well for you. The next one is setting user expectations, as users may see some new errors, some schema errors that they haven't seen before. It's important to set the expectation that we are now doing some additional validation, which is not a bad thing. And since this feature relies heavily on Kubernetes library, and it's important to make sure your version is up to date and keep the Kubernetes cluster as well up to date. And also to roll out gradually, as this diffing is such a core feature of Argo, it's important to roll out progressively instead of all at once to make sure we find any edge cases and get users used to the new functionality. And I have here just the two options on how to enable it. The first one is the annotation we would add to the application, and the second one is enabling it controller-wide in the config map. So key takeaways. We talked about a lot. Hopefully you're not tired of hearing about diff by now. So here are some key points to take with you. So server-side apply is widely considered the gold standard for future to how to manage your Kubernetes manifest. And since server-side diff is using the same, it's also considered the future. And with better CRD support, you'll no longer need as much ignore differences. And you'll be able to catch your issues earlier in the sync stage or in the diff stage rather than the sync. And also performance can be a concern, so just test and monitor carefully. And yeah, thank you for attending our talk. Please scan our QR code, rate our talk, and follow us on LinkedIn. We also have some demos at our booth outside. And yeah, thank you.
Thanks, everybody.